Hey makers, before I show you a little bit more about the 5-cut method, I wanted to say that this next part that you're going to watch comes from a video that I released yesterday. If you're interested in building this, I will have a link down below for that. I also wanted to mention that this is William Ing's method. I'm only showing his method. I have his full video that's going to be in the description as well. Big thanks to him. It's an incredible method, and here's the segment now. But essentially what I'm going to do is make a cut. So I've got my first cut here, make my second cut, make my third cut, flip it again and cut my fourth. And if my fence is lined up correctly, I should have a 90-degree angle in each corner. To check to see if each one of these corners is correct, I'm going to cut a strip off on this side, which is going to be my 5th cut, and then I'll use a caliper to measure the top and the bottom piece of my 5th cut. The 5th cut has the letter A and B written on it. I'll go ahead and check the measurement of both. Letter A is 7035 and B is 0.7195. So I'll take 0.7035, subtract 0.7195, and that comes to 0.016. So we've got a difference of 0.016 inches over a length of 18 3/4 of an inch. That does sound a little abstract, so let's break this down into something that's a little bit more relatable. Imagine the thickness of a standard piece of printer paper, about 0.0039 inches. Our difference here is just a bit more than 4 pieces of paper stacked together, over a distance of nearly 19 inches. That's really tight. But what if we stretch this out? Let's say we're working with a longer board, maybe an 8-foot piece of stock. With the same error per inch, that difference would only be about a 1/16 of an inch from one end to the other. So even if you're cutting something as long as 8 feet, the level of precision would only result in a taper that's just about a 1/16 of an inch. For most woodworking projects, that's incredibly accurate and within acceptable tolerance. But if you really want to get accurate, we can make that error per inch even smaller. I've got William's formula over here. I've already subtracted A minus B. Now I need to divide that by 4, which are the 4 corners. That comes to 0.004. I've already mentioned that the length of this is 18 3/4. So I need to divide that by 18.75. That comes to 0.0002133. Now I'm going to multiply this number by my pivot point and my adjustment. So we're going to make this easy. I'm going to set this, my pivot points over here, I'll set this to 22 inches altogether. So I'll multiply that by 22. That comes to 0.0046933333. Now that I know how far off it is, which way do I move it? Because my fence is on a pivot, I can either move it this way or I can move it this way. Ing explains it like this. The blade and the fence are at a 90. You have 1, 2, 3, 4 all the way up to 90, and then if you go below that, you're going to have -1, 2, 3, 4, 5 all the way down the other way. Because this came out to being a negative number, it means that my fence is too far this way, and it means I need to move my fence this way by 0.004. I calculated my adjustment point as being 22 inches for my pivot point, which is right here. Because I want to move my fence forward, I'm going to take a feeler gauge and place it right against that point. I am rounding this to 0.005, but I'll take a piece of stock with a point on it, and I'll put it right up next to that point. Once I've got it against the point, I can add a clamp. And now I know that at this point right here, it's exactly where I want my fence to be. So now I'm going to go ahead and remove the screw in the back, pull my feeler gauge out, and move my fence just enough to hit that point. Let's say your fence is too high. You'll place your stock against the fence, clamp it down, take the screw out, and then put the feeler gauge between the 2 points and press it forward before drilling a new hole and adding a screw. I'll remove my screw now, and I can move the fence forward just that little bit. It's very hard to see a difference, but there's a slight difference. Now I can add a clamp and add my screw. We'll cut this again and we'll see how close we are now. Letter A is 1.125 and letter B is 1.1255. Woohoo! On the screen now you can either watch the build for the sled up here, or you can go and watch William Ing's video down here. Thank you as always, and remember to keep making things.